بسم الله الرحمن الرحيم. أهلا بكم أهلا بكم أحبتي في درس جديد ومحاضرة جديدة مختلفة تماما عن المحاضرات، ألا وهي محاضرة التدريس الخصوصي لمادة انتقال الحرارة للصف الثالث الهندسي، قسم هندسة المواد الجامعة المستنصرية. الآن نحاول بإذن الله تعالى نحاول توضيح المثال التالي: أنبوب يجري فيه بخار وكمية انتقال الحرارة أو إيجاد معادلة توزيع الحرارة للجانبين الكونفكشن والكوندكشن، يعني للتوصيل وللحمل. So, in the name of God, the most gracious, most merciful, the all self-sustained, here we are again, once again, ladies and gentlemen, and today a brand new lecture, pretty much different than the fourth, or even pretty much different. Today we're just gonna have to visualize a whole new topic, or a whole new set of topics here, pretty much associated to the heat transfer, conduction, and convection, or heat transfer, conduction plus convection, or by process of conduction plus convection heat transfer, with a steam through a pipe here, just to visualize and to extract the temperature distribution equation, or the equation of temperature distribution in the pipe while steam is flowing right through. The example states as follows, or the example stipulate the following. يعني المثال ينص على التالي. example 2 consider a steam pipe، يعني باعتبار أنبوب يجري فيه بخار of length طوله L equals to 15 feet. الطول L length يساوي 15 feet. inner radius يعني نصف القطر الداخلي R equals to 2 inch. The units are measured here in the British system. The units pretty much the units, as you can see right here for you, as visualized, is measured or even is scaled. The units entirely in this example is scaled in British units. يعني in British scale، يعني الوحدات مقاسة بالنظام البريطاني inch وفيت. 2 inch. outer radius يعني نصف القطر الخارجي R equals to 2.4 inch يعني 2.4 inch. and thermal conductivity والتوصيلية الحرارية أو ثابت التوصيلية الحرارية K, thermal conductivity constant K as indicated as K, as you can see right in front of you. K يعني كما ترون أمامكم K equals to 7.2. K يساوي 7.2 BTU H Fahrenheit H feet by Fahrenheit. BTU H feet by Fahrenheit. Steam is flowing through the pipe just like we stipulate، يعني البخار يجري خلال الأنبوب كما أنصصنا at an average temperature، يعني بمعدل درجة حرارة of 250 فahrenheit 250 Fahrenheit 250 degree Fahrenheit، يعني 250 درجة فahrenheit. and the average convection heat transfer coefficient ومعدل انتقال الحرارة بالحمل، معدل انتقال الحرارة بالحمل أو ثابت انتقال الحرارة بالحمل in the inner radius or in the inner surface of the pipe is given as to be H 2 equals to 12.5، يعني معدل انتقال الحرارة بالحمل أو ثابت انتقال الحرارة بالحمل H معطى للسطح الداخلي للأنبوب يساوي 12.5 BTU H feet per Fahrenheit feet by Fahrenheit. If the average temperature in the outer surface, or if the average temperature entirely overall or measured at the outer surface or in the outer surfaces، يعني إذا معدل درجة الحرارة المقاسة في الأسطح الخارجية للأنبوب of the pipe is T2 equals to 160 Fahrenheit degree Fahrenheit، يعني مقاسة T2 equals to يعني تساوي 160 Fahrenheit. A بسم الله الرحمن الرحيم. As you can see right in front of you, if the average temperature in the outer surfaces and the pipe or of the pipe is T2 equal to 160 degree Fahrenheit. A obtain يعني يستنبط a relation for the variation of temperature، يعني يستنبط علاقة أو يستخرج علاقة لتغير درجة الحرارة أو for steady one-dimensional heat conduction through the pipe للحالة المستقرة أحادية البعد، للحالة التوصيلية المستقرة أحادية البعد خلال الأنبوب، يعني في جدران الأنبوب فقط. and B evaluate the rate of heat loss، يعني evaluate the rate of heat generation، يعني عوض قيمة أو معدل الحرارة from the steam through the pipe، يعني من البخار خلال الأنبوب، يعني بالconvection من البلك or from the center, right from the center of the bulk here, right, or what is from the center of the steam, which is considered a bulk block, or the bulk mass going through or flowing through right through the pipe, as you can see right in front of you here, right into the inner radius of the or right into the radius, or even right into the inner lining of the steam pipe, as you can see right in front of you. Inner lining يعني البطانة الداخلية. بسم الله الرحمن الرحيم. Solution الحل. For one dimensional in the radial r direction، يعني للحالة التوصيلية البعدية في الحالة التوصيلية البعدية المستقرة بالاتجاه القطري in the radial direction or in the radial direction of r، يعني بالتوصيل القطري r without heat generation of and steady state، يعني بدون Q، بدون الكيو، يعني بدون توليد، بدون يعني بدون حرارة، لا مو توليد، حاجة توليد يعني بدون حرارة and steady state وحالة مستقرة. As you can see right in front of you, this is the term here for the Laplace equation. Laplace equation states if you actually dealing with a cylindrical object, or you're dealing with a cylindrical pipe or any cylindrical object that with a steam flowing actually through, or even not steam flowing through, is actually heated or heat generated, or experiencing a heat generation as well as experiencing a steady state heat generation or a steady state heat flow through a pipe or even through any cylindrical object consists of inner and outer radials. The optimal equation or the characteristic equation evaluating, or characteristic equation here to evaluate the entire values of rate generation as well as rate or the steady state, and to be derived or even to be modulated here for the cylindrical objects is as follows. يعني الحالة المستقرة، بالحالة المستقرة إذا واجهت جسم أسطواني كأنبوب بقطر داخلي وقطر خارجي يجري خلاله بخار أو وحرارة وتوليد حرارة كذلك، بالأبعاد الثلاثة، السمت، زاوية السمت فيته in whole three-dimensional spatial cylindrical media, which is pretty much considered here in this example as stipulated or even stipulated in the term or even in the form of the cylindrical pipe at which steam is flowing right through، يعني يجري فيه بخار. للحالة المستقرة بالثلاث أبعاد، الR الاتجاه القطري the radial direction of R as well as the azimuth angle as well as the Z vertical or normal axis here. So the steam is flowing actually right in the direction of normal axis R. So all we have to do is to extract or even obtain a temperature distribution equation in the R directional one-dimensional steady state heat generation or heat flow through the by convection and conduction by the by process يعني عملية ثنائية by the binary process of conduction and convection at the same time. So DDR, this is the term DDR, is actually a derivation for the entire inner term, as you can see right in front of you, the entire bracket bounded term of R dt DDR equals to over R dt dr. This is the bracket bounded term or the brackets or the arc bounded term، يعني الحد المعادلة المحصور بين قوسين. R DDR is actually the pretty much considered the derivation or even the derivation or even the change of t with respect to r or the change of r with respect to t equals to 0, as you can see right for you. This is the equation. First integration يعني التكامل الأول يعطي r dt dr، فقط ال r dt dr، فقط ال r dt dr. As you can see, only the term or the bracket bounded term r dt dr will be given in the following example as C1. This is the first constant integration, or this is the first constant of integration, as you can see right in front of you, according to the following or according to the predecessor equation turned to be as 1, or the equation first in the example stipulated or in the example visualized or example visualized right here. ddr will be integrated, or the DDR, the entire term here is actually both hand sides of the equations will be integrated with respect to t, or even will be integrated with respect to r. DDR r dt dr equals to 0. So this is the equation, and the successor relationship, or the successor step of the procedure, as you can see right for you, is considered or even considering the following. First integration gives for the term of the predecessor term or the formal term, as you can see right for you, is r dt dr equal to C1. DDR will be pretty much considered by the integration. The DDR is a differentiation for the entire arc-bounded term. R dt dr will be considered for the integration. يعني هنا فقط المحصور بين الأقواس يؤخذ R dt dr لأن هنا يكامل because the term DDR, as you can see right in front of you, will be integrated, will be pretty much integrated. So the integration of the differentiation will be a pretty much reversal or counter to each other process, or counter to each other task or even procedures. So the entire R dt dr will be considered. The entire term arc bounded terms or bracket bounded terms R dt dr will be considered equals to C1. C1 is the first constant of integration. يعني فقط ال R dt dr يؤخذ ويساوي C1. C1 هو ثابت التكامل كما ترون أمامكم. لذا ستكون المعادلة بنقل R, so the equation will be by transferring R from the left hand side of the equation right into the right hand side of the equation. يعني بنقل R من الحد الأيسر للمعادلة إلى الحد الأيمن بالمعادلة ستكون كالتالي: dt dr will be left alone, will be kept alone and remain alone right into the left hand side of the equation. Only R will be transferred from the left hand side of the equation right into the right hand side of the equation. يعني فقط R ستنقل إلى الجانب الأيمن من المعادلة و dt dr تبقى فقط في مكانها. في البقعة التي هي بها equal to C1R, as you can see, where the C1R, so the R will be transferred into the numerator of the left hand side of the equation. R will be pretty much transferred to the numerator of the right hand side of the equation, as we stipulated before, or as we indicated. يعني R سوف تنقل إلى المقام للجانب الأيمن من المعادلة. This is the equation to consider. Second integration gives the temperature. Second integration gives the temperature integrated with respect to R, or integrated with respect to radial diffraction of the cylindrical coordinates. يعني التمبرتشر هنا بالتكامل الثاني يعطي الحرارة مشتقة أو مكاملة بالنسبة للاتجاه القطري بالإحداثيات الأسطوانية. Radial direction in cylindrical coordinates. Radial direction is going to be R. So dTdr, the integration of dTdr gives T or yields T. يعني تكامل dTdr ينتج T. Produces T or yields T. T is the temperature in terms of the C1 and C2 at the same time, or temperature in terms of R, because the equation is given, or even the internal equation or the characteristic equation here for the Laplace in single dimension steady state and heat ratio is given actually in terms of or in terms of R and T in the same time. So R and T, or T will be integrated with respect to R as the procedure pretty much states. As the procedure pretty much states, T equals to C1 ln R. The C1 to R will be considered as 1 to R. So 1 to R will be considered, or will be integrated in the form of ln function. يعني واحد إلى R تكاملها هو عبارة عن يعني هنا دي ار سوف تنقل كذلك، هنا دي ار هم ننقلها كذلك لهنا. As well as the dr will be transferred from the left hand side of the equation right into the right hand side of the equation, as you can see right in front of you with the C1 to R dr. C1 to R dr. So dr over R will be considered and will be consequently or even subsequently integrated in the form of ln function, ln of R. The ln of R يعني دي ار بنتنقل إلى هنا سوف تكامل تصبح دي ار إلى R يعني مشتقة ودالة. So it's going to be like in the form, or they're going to be a fractional term of the derivative and its function, or derivative and a function at the same time. So the integration of the derivative and a function in the form of a fraction will be integrated, but the integration will be in the form of ln R, ln of the function here, just because the availability of the derivative of the function is actually pretty much available or provided in the denominator of the fractional function. يعني لأن المشتقة الدالة موفرة أو متوفرة في denominator، يعني في البسط للدالة. لذا ستكون C1 dr إلى R تكامل nr ln R. dr لأن نقلناها إلى هنا، dr نقلناها إلى هنا just because dr will is transferred right from the left hand side of the equation right to the dr or right into the right hand side of the equation, so it will be integrated in the form of nr ln R, as you can see C1 ln R plus C2. C2 is the second constant of integration. All you have to do is concentrate, and the mathematical or the arithmetical procedures we are about to proceed, or actually we're proceeding here to integrate as well as to obtain the optimal the optimal equation here for the temperature distribution, and subsequently will be treated in the form of or to extract or even to obtain the temperature distribution as stipulated in the example or in the example paragraph, as you can see right here in front of you. يعني هي الخطوات المثالية لاستخراج أو لاستنباط التي كما هو موضح أمامكم بالمثال المنصوص عليه هنا. استخراج التي والعمليات اللاحقة كذلك subsequent procedures، يعني الإجراءات اللاحقة لإيجاد معادلة توزيع الحرارة justifying or just to obtain the temperature distribution equation, the optimal form of temperature distribution equation here to be subsequently find or to be subsequently obtained by using the following t-term. Extracted or obtained from the second, or produced from the second, or yields from the second integration of the dtdr equals to C1R. As you can see, this is the equation 2 of the course. BCS is the boundary conditions يعني الشروط الحدية أو الشروط الحدودية. At R equal to R1, as you can see, with R equal to R, Q over A or Q to A equals to H, T steam to T steam T، يعني H هو ثابت انتقال الحرارة بالتوصيل بالحمل is the heat transfer coefficient or the convection heat transfer coefficient to the H here is indicated here right in the right hand side of the equations equals to QA. QA is the Q is the heat generation as well. Q is the heat transfer flux. Q to A is the heat transfer flux. يعني Q إلى A كما ترون Q هو heat generation or the heat flux. As you can see right in front of you, this is the heat flow. Q is the constant of heat flow or the heat energy. يعني Q هو الطاقة الحرارية أو الفيض الحراري. A equals to H. Heat transfer coefficient H is the heat transfer convection or convection heat transfer coefficient. يعني معامل انتقال الحرارة بالحمل. By T steam درجة حرارة يعني T steam is the temperature of the steam flowing through the pipe. يعني درجة حرارة البخار خلال الأنبوب. T هي درجة حرارة السطح الداخلي. T is the inner radius or the inner lining or the inner surface temperature as you can see from steam to the pipe. This is from the steam to the pipe. يعني هنا المعادلة تؤخذ هنا نحن نستخدم معادلتين في in this track يعني في السؤال. In this track, we're just going to have to use both equations here for the conduction from the inner to outer conduction or the inner to outer heat transfer, as well as we're just going to have to use the convection equation or the convectional optimal standardized equation of Q to A is equal to QA equals to HT steam and T just for the heat transfer from the fluid, or if you transfer from the steam or the vapor right into the inner lining or right into the surface of the pipe. يعني نستخدم معادلتين هنا لانتقال الحرارة من الستيم أو من الماء من الستيم يعني من البخار إلى الأنبوب بالحمل، وكذلك انتقال الحرارة خلال الأنبوب نفسه as well as the temperature heat transfer or the temperature transfer through the pipe itself or through the pipe himself here will be considered as the optimal or standardized equation for the conduction heat transfer, as well as QA equal to salib K or equal to K dt dr. dt dr هي معادلة التوصيل. This is the standardized conduction equation. يعني هي معادلة التوصيل القياسية. i.e. يعني نساوي بين التوصيل سوف نساوي هنا بين التوصيل والحمل. يعني نعتبر قيمة التوصيل نفس قيمة الحمل. We're just going to consider the both values of convection and conduction are all in the same page. So we just have to equalize as we're equating the values of conductions through the lining itself or even through the pipe, just like we stipulate, as well as the convection heat transfer or the convection values will be considered for the pipe or will be considered from the steam to the pipe as equal to the conduction standardized terms as you can see here as indicated by the K dt dr. يعني هنا سوف تعتبر معادلة الحمل مساوية لمعادلة التوصيل. So K dt dr, this is the standardized equation of conduction equals to H. K is the thermal conductivity given in the question. يعني K هي ثابتة التوصيلية الحرارية المعطاة في السؤال. As well as the H is the convection heat transfer coefficient. يعني H هو معامل توصيل الحرارة بالحمل معطى كذلك في السؤال. T steam معطاة في السؤال. وT كذلك. So the K dt dr equals to pretty much the equating between the both equations right-handedly or even left-wise and right-wise. This is the left-wise and this is the right-wise. Left-wise يعني على في الجانب الأيسر و right-wise بالجانب الأيمن. At R equals to R2 يعني في at BCS of R equals to R2 and T equals to T2. This is equation 5 of the course, or this is equation 5 of the track here, stated or stipulated by the boundary conditions. يعني هنا المعادلة الخمسة للمعادلة الشراء والحدودية 2 عند R يساوي R2 يعني السطح R يساوي R2 في النصف القطر الثاني T equals to T2 يعني درجة الحرارة تساوي T2. This is the equation 4. Here, this is the equation 4 for the BCS1. This is the equation 4 pretty much indicating the standardization of BCS1 or the modulation of BCS1. هنا المعادلة 4 تنص على تضمين أو تنص على نمذجة boundary condition أو نمذجة الشرائط الحدودية الأولى. نمذجة الشرائط الحدودية الثانية ستكون كالتالي. Applying boundary conditions gives K C1 R1 C1 as you can see C1R حشران equals to H T steam C1 ln R1 plus C2 at R equals to R1. This is the equation 6 of the course. T2 equals to, since we have T2 here and previously or formerly in the question, T2 equals to C1 ln R2 plus C2. C1 ln R2 plus C2. Ln R is the integration of the function or fractional form functions with the derivative in the denominator as well as the function in the in the denominator. يعني هنا اللين R2 هو التكامل الدالة على شكل كسري، تكامل الدالة على شكل كسري في المشتقة في البسط والدالة في المقام. هنا K C1R as you can see right, this is the K1 C1R as indicated before. K C1R. Here is going to be the DTDR will be evaluated in the form of C1R according to evaluation or according to the application of boundary conditions to the following heat conduction equating or the heat convection equating standardization term. يعني هنا سيكون ال K وال C1R سيكون هنا ويعوض بدل ال DTDR كما ينص معادلة أو كما تنص معادلة أو كما تنص العملية أو الإجراء لمعادلة التوصيل بالحمل. Equals to H will be given here as follows. The T steam is the T steam and T steam is given in the question. يعني T steam هنا يعني درجة حرارة البخار المار خلال الأنبوب. T steam is the temperature of the steam or the vapor air flowing through the pipe or even the steam flowing through the pipe. So and the T will be considered as T. T هنا كما ترون أو T هنا بالحمل. T is actually in the convection or the in the convection term, as you can see on the right hand side or the rightwise of the equation or right hand side of the equation is actually indicating the T in obtained from the integration of the second integration of the dr dt or dtdr. يعني هنا T مستنبطة من التفاعل أو مستنبطة من التكامل الثاني ل dtdr. التكامل الثاني هو T يساوي C1 ln R plus C2 C1 ln R زائد C2. So the T is actually indicating the C1 ln R1 plus C2, as you can see this at R equals to R1 and at R equals to R2. T2 equals to C1 ln R2. T2 equals to C1 ln R2 plus C2. T2, just because we have the T2 here, that the outer surfaces of the pipe at which the steam is flowing right through. يعني هنا عندنا T2 في السطح الخارجي السطح الخارجي للأنبوب الذي يجري فيه أو الأنبوب كما ترون. T2 will be dependent or even will be considered as the T of second integration as the T obtained from the second integration of the dTdr according to the Laplace single dimensional steady state heat generation equation. T2 equals to C1 ln R2 plus C2 at R equals to R2. يعني هنا المساواة في R equals to R1 يعني هنا المساواة بين الحمل والتوصيل. وفي R equals to R2 يعني R تساوي R2 فقط تأخذ المعادلة للتوصيل فقط، لأن R2 السطح الخارجي فقط يعنى بالتوصيل، يعني توصيل من السطح الداخلي من السطح R إلى السطح R، التوصيل فقط من السطح الداخلي إلى السطح الخارجي أو السطح الخارجي إلى الداخلي، السطح الخارجي إلى الداخلي. Here the equation will be considered or will be considered only for the outer surface of the pipe at which the steam is actually flowing right through, and will be taken as in the form of the second integration of the dTdr according to the stipulation of the second integration of T. This is the T is actually pretty much equals to T2. T2 or T2 in turn is actually pretty much equals to T. T equals to C1 ln R2 plus C2. Will be taken here at the outer surface just because we have the conduction process is applied. At the outer surface of the steam pipe, as you can see right there, but at the inner surface, or between this, right in between the steam flowing right through the pipe, or flowing right through, or the steam itself, or the steam himself is actually conducting or even transferring the heat right to the pipe by using the convection mechanism, as well as from the inner surface, or from the outer surface, from the outer to inner surface of the pipe is actually the heat transferred by the mechanism of conduction. So between the steam and the inner surface of the pipe is the heat will be transferred in the mechanism of convection. But from the inner surface, or between the both radiuses, or even between the both surfaces of the pipe at which the steam is actually flowing through, the evaluation of the entire terms of the evaluation of the entire values will be evaluated, or even will be compensated, or will be evaluated and applied by using the mechanism of conduction. Solving for C1 and C2 gives يعني استخراج C1 و C2 ثوابت التكامل. Here the extraction of or the obtention or the extraction of the both C1 and C2. The integration constant as indicated gives C1 equals to T2 minus TS or the T2 T2 TSD ln R2 or ln R1R plus K HR as you can see as indicated. So and C2 this is the C1. answer question for the solving for C and C2, C1 and C2 by the following stipulated equation, as you can see right in front of you, or by following upward equations of 6 and 7. Here, C1 and C2 will be pretty much, or will be completely extracted in the following optimal manner, and C2 equals to T2, C1 ln R2 equals to T2. As you can see, C1 ln R2 will be evaluated as in the form of T2 T steam, as you can see, as indicated right here for you, in R1 to R plus KHR. Ln R2, the C1 completely will be evaluated right into the equation of C2 as is indicated right here, just because we have a C1 here, C1 extracted before and extracted formally, so the C1 will be evaluated in turn, or it will be evaluated in turn, as you can see, or as indicated right here before, right into the C2 equation. C2 indicates as follows: to extract C2, T2 should be applied, or T2 should be inserted to the left hand side of the equations instead of C2, and C2 should be replaced or transferred to the out, or even transferred to the open, such as the open is indicating the left hand side of the equation. So the C2 will be transferred to the left hand side of the equation, as well as the T will be replacing the T, or will be replacing pretty much the C2 here in the right hand side of the equation. C2 equals to T2 T2 C1, or T2 C ln R2 equals to T2. This term, as you can see, rather this term, يعني هذا الحد كما ترونه أمامكم هو C1 هو C2. As you can see, this term is actually right in front of here is actually indicating that the C2 is pretty much completely and entirely evaluated in the equation of C2, or in the equation of C1, and inserted partially or inserted completely right into the equation of C1. So the T2 indicates T2 TST ln R1R plus KHR ln R2. This is the ln R2, as you can see already. This is the ln R2. This is the ln R2 as indicated. Subject with C1 and C2 in the equation, or evaluating C1 and C2 in the equation 3 gives T in equation 3. All you have to do is remember the equation here. All you have to do is recall and rewind the equation to equation 3, and you figure out the way I'm talking about it here. T equals to T2, as you can see right in front of you. This is the temperature distribution equation. equals يعني هي معادلة انتشار الحرارة أو معادلة توزيع الحرارة بالنسبة لأنبوب يجري خلاله كما ترون ماء. And for a pipe is actually at which a fluid is flowing, or in which or at which a fluid is flowing right through, at which a fluid is flowing right through, equals to T2 T, as you can see right in front of you, ln R1R plus KHR ln R2. The rate of heat generation, or the rate of heat conduction through the pipe, is Q equals to K A D T D R equals to K. This is the this is actually the considered, or be taken as the second requirement, or even the request 2 of the stipulated example. This is the request 2 of the stipulated example. يعني هنا المطلب الثاني من المثال المنصوص عليه أو المثال المنصوص به. The rate of heat conduction through the pipe is, this is by conduction، يعني كمية الحرارة أو معدل الحرارة، معدل انتقال الحرارة بالتوصيل خلال الأنبوب هو كذلك. The rate of heat conduction, heat transfer by conduction through the pipe will be done, or will be even derived, or even will be proceeded as follows. Q equals to Ka dTdr equals to K 2 by RL. 2 by RL is the pretty much the surface area of the tube, the surface area of the pipe, or even of the tube. يعني المساحة السطحية للتيوب هي 2 by RL. 2 by RL. The heat conduction through the pipe, يعني تأخذ المساحة السطحية فقط. So just by saying here, just by requesting the heat conduction, or the rate of heat transfer by conduction through the pipe, the 2 by RL, which is the surface area of the tube, or the surface area of the pipe at which the steam is flowing right through, or at which the fluid is actually flowing right through, not to mention the steam, just because the steam is way too greater to be mentioned in simplest as we're actually having right now. So the surface area will be taken as 2 by RL. 2 by RL. R is the range of reflection, as was the L is considered as the Z axis, or the Z normal axis of the cylindrical coordinates, or expressing by cylindrical coordinates. C1R equals to 2 by KL C1, as you can see right in front of you, equals to 16,800 BTUH. 16,800 BTUH يعني 16,800 BTUH بالوحدات البريطانية هو rate of heat conduction. يعني هناك 2 باي ار ال تأخذ المساحة السطحية. The surface area, which is the area considered from the or the area considered in range, or the area range from the beginning, or the area range from the between the both ends of the pipe, or the both ends of the tube, actually at which the fluid is actually flowing right through. تم بحمد الله رب العالمين.